Hello and welcome to the 17th Pygame tutorial. Now, you'll notice the screen is zoomed in a little bit, and that's because I'm going to start explaining something. Now, today what I want to work on is maps. So what we're going to do is in our game, we're going to create a background map. So if I actually run this real quick, you'll be able to see a lot less, but you'll still get the idea. When we actually play it, then when we come over to the edge of the map, and I'm going to have to tinker with this a little bit. So when we come over to the edge of the map, instead of like falling off the edge, we actually start scrolling across some type of map. Now, to do this with Pygame is we don't really have control of a camera, meaning we can't just, change our cameras how big the game window is. So on the game window, the top left corner is always going to be 0, 0, and the bottom left corner is always going to be the max value, which is 1000 by 600. That's always going to be the bottom right corner, and the top left is always 0, 0. That can never change. And we can't grab the camera like I can my little recording window and drag it around. We can't do that. But instead what we have to do is we have to grab the actual background image and drag it around instead. Meaning, instead of, grabbing the camera, which I'm holding onto right now and just kind of moving it about, we would have to grab the background, which essentially gives you the exact same result. Visually, through the view window, you can't tell the difference. However, you have to program it a little bit differently. So how about I go back to our normal size for recording these, and we'll get started with the map. Alright, so what I have planned to do is this example right here. So I'm going to run it, center it on the screen, and you'll notice I just put the change in color tiles that you can actually see the movement. But what we have here, this is just kind of our example window, is when we move over, you'll notice the camera kind of pans, but it's not actually the camera panning, it's the background sliding. So I'll move to the right. You'll notice again the camera looks like it's following our player. However, that's not what's happening. What is happening is the background, these gray boxes, are actually moving to the left. So we aren't really moving to the right. The boxes are just moving to the left. And the player is actually being drawn onto this image. These boxes are one big image, and it's being drawn onto it. So when it moves over, our player also moves over, which is why our player doesn't look like it's moving. And of course, this works in all directions, so that you can see, of course, with a little bit of margin that it doesn't change. That's just a kind of personal preference to have you be able to move a little bit without the camera panning, but then once you move outside of this little center box, you start moving again. And when we reach an edge, instead of, going over the edge, what happens is the camera stops. It doesn't let us go past it, so that we can't see past the map, because the map is the border of where we're going to be looking. Now, for this example, I don't have the player safely inside the box. The player can still leave. That's something that we'll just have to work out, because inside this example I didn't have access to the player class, so I just wasn't able to add that, but we will be adding that. So instead of the player falling off the map, they just kind of hit it, and regardless if you keep holding up, the player still just stays at the top of the screen. That's what we're going to work on. So to get started, this will be easiest if we just, create a new Python file, because organizing things in files are always nice. And let's just call this one, it's a map, it's a background image. How would we word this? Just call it a background map. I guess that'll work. Call it this, and I just want to drag this over, probably about here, and do our standard stuff. So we're going to import Pygame. We're also going to, anything else we have to, probably just Pygame, and maybe utils. Yeah, so import Pygame, utils, pygame.init, and there we have it. Now we just need some kind of class, and we're going to call this one, should we call it map? I think calling it map is a bad idea because Python actually has something called map already. How about game map? It doesn't add anything, so define in itself. And inside of our game map, we need a couple things. The first thing I'm going to do is I'm actually going to create a none type object, and I'm just going to call this self dot map image, which is I'm going to explain why I'm setting this to none. It's because we're going to create this thing. Now you could load this thing in. You could say, pygame dot image dot load, and then give it whatever your directory is. So it'd be like background.png, and then that would load in the image, and that would work too. But we're just going to create it because we don't have an image on hand to load in. So we're just going to create this set to none. We're going to probably do some type of function call here, you know, like make image. And then we need self.active. How would I word this? It's the used image, because we need two types. We need the base image, which is the thing we copy from. So we only generate it once instead of regenerating the image every single tick of the frame. Because remember, we have to refresh it. So we have to basically undraw the whole thing by clearing out the game window and then redrawing it. So we need a fresh copy of the image every time. So that's why we have a map image, which is something we don't edit. And then we also have, you know, I guess I'll just call it an active image, which is kind of what we use, or I should call this maybe active map. This is the one we see, and this is just going to be equal to the image copy. But I'm also going to set it to none just to start with, because when we create the map, we don't know what these are yet, because we haven't created the image. So what else do we need for the map? Well, because the way the map works, when we go left and right, so if I open this up again and show you, because the way the map works, we need some type of offset. Because if you remember, when I'm moving around, my blue box isn't actually moving. Well, the blue box is moving, but the camera isn't the thing that's moving. The background is the thing that is moving behind our image. So we need some type of offset. So we need, you know, let's call this offset x. This will equal 0 to start with, and self.offset y, and this will also be 0 to start with, because the x and y is where we're blitting it, because we blit the map image to the game window at a certain offset. So again, I'm going to run this example just to show you this, because it's kind of reverse what you might expect to think. So let me go over to the top left corner. The top left corner is 0, 0 on the map. This is where it would be blitted normally. Now, when I move over to the right, what's happening is now I'm blitting it at something like -5 in the x. And now it's, you know, negative maybe 200 in the x, -400, -600. That's the offset. That's where we're blitting the image, because that's what it needs to look like. We need to kind of treat this in reverse, since we can't affect the game window. This image right here, so this is always the top left corner, and this is always the bottom right corner of the game window. So this is always 0, 0, and this is always whatever the max you have for your size of the game window is. Those can never change. And because that never changes, even when we scroll down or scroll to the right, those are the same for the game window. However, the map is just being, you know, added to the image at an offset. And that's why it kind of looks like it's moving around. So our map needs possibly another couple functions. Or another couple variables. I'm just going to define some functions right now. So we're going to have one called create the map. And this is going to be the thing that actually generates our map. And of course, we're just going to pass these for now. We also need to define reset map, which is going to reset it for every frame. This way, you know, if we need to do some stuff like when we redraw the map, we take another copy of it. This is what we do to actually kind of reset what our map is looking like. And then the standard update, which is just something the map is going to be doing every single tick to, you know, ensure that it's working, which is where our scrolling will happen. So let's start by taking a look at create map. To create a map, what we need to do is we need to basically define how we want it to look. And I'm going to do the same kind of checkerboard patterns that we can see the movement of it. So create map. This is going to take two things. First, we need to kind of, I guess, decide the size of our map. Like, how big do we want it to be? So I'm thinking a bit smaller than the example. So let's try and go with probably 2000. So self.map image is going to equal a pygame.surface, and this is where we set our map image. This is the entire map, the big map piece. So let's go with 2000. 2000 by 2000, just one big square, and that's what it's going to be. Now for the checkerboard pattern, I'm going to use two additional ones. So or I don't even need to say self for these because these are only in created map zone. So we'll go with a light tile, and this will be a pygame.surface of probably 100 by 100. And of course, I'm going to just copy this. And this one is going to be the dark tile. Of course, we can use any color we want, or we can even load in images for these tiles if we wanted to, but that's not what this is going to do. So light tile, we're going to say light tile.fill with a tuple, and this one's going to be probably 160, 160, 160. These are colors we don't have defined, which is why I'm not, saying utils.pick a color. Dark tile.fill. Let's go with a much darker color. So 50, 50, 50. Of course, these are close. This one's closer to black. This one's closer to white, meaning this will be sort of a light gray to grayish color, and this will be sort of a dark gray. And now all we have to do with these tiles is split them to a bigger image. So right now, and I'm actually going to pull this thing out because I find this thing to be useful sometimes. So we have our big map, right? This is my terrible drawing. All we're going to do is take a light tile, split it here, take a dark tile, split it here, take a light tile, split it here, take a dark tile, split it there, and then, repeat this kind of action where we're just splitting these tiles onto our main image. Until, of course, we create this sort of checkerboard. And that's me drawing with a mouse. It's very, very artistic. But to do this, what we're going to say is for x in range, which I don't think I've even done this yet, and this is one of the main way to do loops in Python, is just saying for x in range, start, end, and what's our end going to be? Well, for tiles are 100 wide and we have 2000 pixels that we need to cover, this will be 20. So for x in range of 20, so basically this loop will happen 20 times, we're going to say for I in range 0 to 20, this one will also happen 20 times. Of course, this is because our x and our y are the same. So, of course, y is going to happen first. So, I guess if I wanted to be technical, I should be saying for y, meaning this is the y number, the rows, and this will be the columns, so that you guys can understand that, because y, this is the outside loop. So we're going to, again, with this thing, we're going to start here. And then this is x equals 2, x equals 3, x equals 4, y equals 1, x equals 2. So y goes down, x goes across. That's how this works. So all we're going to say is, if we want to alternate it, I guess we also need one more member, and that's just going to be toggle equals true. And now if toggle, meaning basically if toggle is true, which one are we going to blit? Well, we're going to say self.mapImage blit the, let's just go with the light tile. Blit the light tile to where? Well, we're going to blit it at the x position, so x times the tile size, which is 100. So at the start, it'll be 0 times 100, which is 0, so we'll blit it at 0 in the x direction. And then on the second one, it'll be x will be 1, and it'll be 1 times 100, so we'll blit it at 100. And then 2, it'll be 2 times 100, so we'll blit it at 200, which will just, keep blitting it wherever we put it. Of course, we could, create a variable called tile size or something, but we're just going to use hard-coded values for now, because our tiles are just going to be the same size no matter what. That's going to be the x position, and the y position is going to be the same thing, y times the height of our tiles. And then we're just going to say toggle equals not toggle, which is just inverting toggle. This is the way to invert toggle. Of course, toggle, instead of being a Boolean, we could set it up to be, 1 and then just multiply it by -1, so it inverts every time anyway. And then else, meaning if toggle is false, we're going to say pretty much the same thing. Self.mapImage.blit the dark tile at x times 100 and y times 100. And then we're going to say toggle equals not toggle. And what this is going to do is it's going to essentially create our map by blitting our different tiles. Of course, we could have multiple tiles if we wanted. This is just a checkerboard pattern. You could have multiple different images. You could have this set up in any way that you want to create it. We're creating a very linear tile set. If you wanted to create something like, how would I put it, sort of in an art more of a like turn-based strategy or some type of game where you have, tiles that are unique, then this is also where you would handle your map data. So what we would say is something like, map data at X and at Y. So at this position in our map, equals 1 for being a light tile, and maybe here it would equal 2 for being a dark tile. And that's how we would set up our map data wherever we create it. And of course, we could put lots of different conditions on this, but we're not really creating a randomly generating map. We're just creating a simple background. So we have a little bit more, space to play our game with. So this should create our map if I am correct. I don't see, yeah, this will make our map, and self.mapImage is being equal to this. Since we're not refreshing it, it's always going to look like this every single time. We're only going to ever call this once, and we're going to call it right here. So this is where we make the map. We're just going to say self.createMap. And this, and I need an E there, this is going to make mapImage equal to this whole checkerboard pattern we just made. And once mapImage is equal to that, ActiveMap is the thing we're actually going to be using. But we're never going to change mapImage. MapImage is only going to be, affected directly in createMap, which is only ever called when the game map is created, because there's no reason to. So what is ActiveMap? ActiveMap is what we're drawing to. It's what we're basically using for our game. So it's the thing that we see. The map image is something we don't edit. The active map is something we do edit. We draw the player on it, we draw the enemies on it, we draw our objective on it. That's the thing we draw our stuff to. So, in order to do that, what we're going to say is reset map. Well, I create a variable for this even though it's really simple. This is just saying self.activeMap equals self.mapImage.copy. Because the copy of this is when you say self.surface, self.pygamesurface.copy, it takes a copy of it. It doesn't add the original. If we leave this out, if we leave the .copy out and we just say this, then it's basically saying, okay, self.activeMap is now a pointer to the map image object, so that they're the exact same object. Meaning if we edit map image, active map image changes. If we edit map image, active map changes, because of the same thing. But by saying .copy, what's happening is we're just taking it and we're creating active map as a map image, but as its own object. So we're just stealing a copy of it without changing map image or tying map image and active image together. Now, sometimes when you reset your map, say if you had the map data, you might want to do more stuff. Or maybe we might want to do more stuff later on, depending on how our game develops. But for now, this is all reset map is really going to do. So now that we have our map, let's actually start, adding it into the game. So our map will draw. We can, draw our map on. So let's add it. We haven't done scrolling yet, but we'll get there. So now we have to import some more stuff from, and probably this is way too much importing, but it works. It keeps things a little more organized so that you guys can see what kind of associates to what. So from background, map, import game map. Because we just want the game map. We don't really want anything else, so there's no point importing the whole file if we're just looking for game map. And the game map we are going to add somewhere. Actually, since we made this a game object, let's put it by all of our other things. So self.map is going to be equal to a game map object. So now we have our map. And when we create the game, let's not create the map just yet. Let's wait until we actually enter the physical game. So we go to the menu. Once we come out of the menu, I suppose we could create the map before we go to the menu. Just kind of depends on when we want to create it, but I'll just say self.map. Actually, we create it when we instantiate the object, didn't we? So it's no point even trying to create it later. Yeah, we create the map when we instantiate the object. What am I thinking? Alright, so we have the map. It's active and working. But in order for things to actually draw to the map, we have to almost change up our entire drawing system. So remember at the start, we basically blank out our game window. Well, we still do that, but now what we also do is we have to say self.map reset map, because we need to reset the map. We need to take a new copy of it, because us blanking out the game window just fills the game window with white, so we have a clear palette to draw on again. Well, after we've drawn on the map, we have to reset the map so that we have, again, a clear image to draw upon. So when we say self.map.resetMap, we're grabbing, a fresh copy of our map so that we can draw all the new stuff onto it, so that the old stuff isn't still there. And now when we actually do all of our drawing, instead of passing in the game window, we have to now pass in the map, because instead of everything being drawn directly to the game window, we're drawing it to the map now instead. So let's see. Where do we do any drawing? So I'm just looking for stuff where we mostly pass through. Like, for example, all these updates, we pass in the game window for everything. So I'm just going to make sure that we don't draw it elsewhere, I guess. Yeah, I think this should be okay. I don't really see us drawing to the screen other places. So instead of saying game window, we're going to say self.map.activeMap. And this is the thing we're now going to be drawing to, because this is the new surface we want our game to be taking place on. So I'm just going to take a copy of this and put it everywhere that it says self.gameWindow instead. That way we draw onto the map. And of course this might take a little more tweaking just to get it working 100%, as there might be some things that I'm not quite paying attention to. On where else we might draw, I know we do some drawings elsewhere possibly. I don't think we just confined it to these 4 things. But once we do this, once we have everything draw to the map, so we grab a fresh copy of the map, we draw everything to the map, now we just blit the map. So down here, before we update the display, before we update the game window, what we say is self.gamewindow.blit self.map.activeMap, which is the thing we just drew to, and we blit this at self.map.offsetX, self.map.offsetY, and that's where we draw our map. So once we, do everything in our map, we draw it here. And now that I think about this, before we actually drew our map, what we do is we'd say map.update or self.map.update. But what I'm thinking is maybe I'll just call this draw inside the update function. But this is how we're going to be updating. We just update, we blit the map onto the game window at the offset, which allows us to scroll. So currently we're just going to blit it at 0, 0 because that's what those 2 values are. So what I'm actually going to do is I'm actually going to get rid of this and just call that all in the update by handing it self.gameWindow. It doesn't take the argument yet, which is why it's complaining at me. So come over here, that's reset map, and then the update will just take a game window, and then we'll just call this. And of course, fix this up a little bit. Instead of saying self.map, I can just say self.activeMap, self.offsetX, and self.offsetY. Okay, so now we're drawing the map. Now this should work. Let's run it, make sure. Alright, of course this would run anyway because, well, I guess we did draw the map. But now that we play it, we have a bit of a problem. One is we still have that white box that we're drawing from the scoreboard, which is something we might have to fix later. And 2, we didn't get the checkerboard pattern I thought we would get from this. I wonder why that is. Oh, it's because we have an even number, that's why. So, couple of things, but you saw the map was being drawn and nothing else was really being drawn kind of intrudingly. It was still working the way we would expect it to. Some of these we aren't going to draw on the map. For example, the scoreboard, probably still going to draw it to the game window. And I'll actually swap that out right now because I think that might just fix the problem we had, but it might not. I just want to test it real quick. Yeah, it's having an issue here, so we'll work on that. But right now I'm just trying to get the map working, then we'll fix any issues that arise from putting the map on. So the reason the map was all kind of striped instead of checkerboard was because we did something wrong. This is an even number. Because it's an even number, it means when we toggle, we start with one color and we end with the other color every time. That means we start with the same color in every single row. In order to fix that, all I would have to do is change up this value to be, 21, for example. So if we change this value to be 21, so I actually don't have to change up the size of the surface. I thought I was going to have to change up the size of the surface, but I shouldn't have to. This will blit at on round 20. Yeah, this will blit too big, so I will have to change the size of the surface. Sometimes when you start counting at 0, things get a little weird. But now this should work because now it's uneven. Let's run it. Let's play it. There we go. Nice checkerboard pattern. That's what I was looking for. So now that we have an uneven number of these, so it starts with white and ends with white over on the right side, that means we kind of create the checkerboard. So one issue that we're having is currently, if you notice, well, the map doesn't scroll with us, so that's a problem. We need the map to scroll with us. So we'll start working on that now. But here's the thing, you have the map drawing now. So now the map is drawing and nothing about the game has actually changed. And before I forget, I'm changing our number of lives. We now get 30 lives because it kind of annoys me when I'm trying to explain something and we keep dying. So now we get a lot more lives to make that work better. So let's finish up with that. Let's at least get the scrolling working, and then we'll be done with this video and we'll fix up the other problems next time because this is taking longer than I thought it would. So, scrolling the map. Well, we're going to handle this one in Update, and we're going to handle all of the scrolling possibilities before we draw it. So how we would do this is we do something like, do normal scroll, and then we would test the boundaries. And I'm going to start with that just because it's a bit easier. So we can say something like this. If self.offset x is greater than 0. Now, think about how this is. If the offset on the x direction is greater than 0, meaning if we're blitting the map to the left, more to the left of the game window, so if we actually run the right thing, so what this is saying is if we're ever running over here and we're ever trying to blit this more to the right side, meaning the offset in the x direction is greater than 0, what do? Well, we don't want that to happen. You see, what we want is if that were to happen, then the map would keep scrolling as we went. But because that doesn't happen, you'll notice the map stops scrolling so that we don't get the white space behind it. What we get is the constant look of the map. So when we say if the offset in the x direction is greater than 0, this should never happen. So all we're going to say is self.offset in the x direction is going to be equal to 0, because that's the most it can be equal to. It can only ever be 0. Because when the map moves, since the top left of our map is always going to be 0, 0 at the most, and then at the most when we go to the bottom right, it should be, whatever the x, the size of the map minus the game window's height / width for our maximum. And that's what we get for the max size. But what this is going to do is this is going to limit the map's scrolling potential to the left side. And if we say elif self.offset in the x direction becomes less than, this would be the game window width minus the map size, because this is actually a negative number we're looking for. So we know the game window width is, actually we're given the game window, so I can just say game window.getRect, and I'm just going to word this differently. So what I'm going to say up here is rect equals game window.getRect, just to grab it once because we're going to use it a little bit. So if the offset in the x direction is less than rect rect.width minus self dot, I don't have a rect on this thing, do I? It's 2100, so I could just, give that a solid size. But what if we ever wanted to change the map's background size? I'm not going to focus on that right now. We're going to just say, we're just going to say minus 2100 pixels. And what this is going to do is we know the width is 1000. So our game window in our actual game is 1000 wide. So when we say 1000 minus 2100, that leaves us with 1100. Meaning if we're ever offsetting, we're ever blitting this image back toward the left side more than 1100 pixels, that means on the right side the map would kind of overreach, meaning the map would come off of the side of the screen so that we would see, the white void behind it, which is just the game window. But we don't ever want to see anything but map. We want to constrict our view, and this constricts our view. So if this is the case, all we say is self.offset in the x equals negative equals rect.width minus 2100, because this is the number we're looking at. It's just the game window's width minus the width of our map. And of course, this is spelled wrong, first off, but this will always constrict us on the x direction. And of course, I just use if and elif because only one of these can ever be true. So if this one ends up being true, you know for a fact this one won't be. So it just kind of halves the processing instead of checking both of them. And then we do the same thing for the y-axis. So if self.offset y is greater than 0, then we know we shouldn't be moving the map down anymore. So we can just say self.offset y equals 0, because the y should never, otherwise the map would scroll too far down and we'd see the white space on top, equals 0. And then elif self.offset y is less than rect.height minus the height of the map, which is again 2100, just for this example. Self.offset y is going to equal rect.height minus 2100. If I can ever hit the right number keys. Now what this is doing is it's constraining us. So again to the example, because it's very useful, and it's why it's here. Whenever we come up here, the camera is trying to actually scroll right now. But because I'm saying that it's not allowed to, or I'm saying that whenever the rect of the map becomes, the 0 on the y-axis, because this is 0 right up here at the very top is 0, that wants to go down some so that we can scroll. But when it goes down, when the update of the map hits, it goes, if you're greater than 0, just set yourself to 0. And then it sets it back. That way we just always see it at 0. And the same thing with the left side. This is the 0. And once it tries to become greater than 0 by making the map scroll toward the right side, then of course it just resets it so that it doesn't actually do that. So this is confining the map. Now, how do we do the normal scroll? This depends on how you want the scroll to happen. So for our example, what we want to have happen is we want it to sort of follow the player. And to do that, we're actually going to need one more data element for this. We need a player rect. And of course, to get our player rect, all we have to do is come back to main. When we update with the game window, we're also going to update it with self.player.rect. Because we don't need the whole player, we just need the rect. That's good enough. So we have our player rect and doing our normal scroll. So we don't need this anymore, I guess. Give us a little more space to work with, just so you can see where I'm working. And I can see where I'm working, I guess. But to do this, what we're going to say is if the player rect.center center x, so if the center in the x position of the player becomes greater than the game window rect.center x, so if our player's center in the x direction becomes greater than the center of the x direction of the game window, what we're going to do, well, of the game window minus self.x offset x, because if we're offsetted, then this will be a different problem. So this just, takes care of if we're not in the top left corner. So what we're saying is if our player's center becomes greater than the center in the game window, what we're going to do is we're going to scroll. So we're going to say self.offset x. I believe this one is minusing because if we're more to the right than the center of the game window, then the map moves to the left. So I'm going to say minus equals self.scroll speed. And I don't think I created that one. I didn't, so we'll just create that up here. Self.scroll speed. And I'm going to conveniently set this equal to our player's movement speed, just so that it, matches his movement speed. If this was slower, then our player could kind of move off the edge of the map. If this was faster, then it would be a little jittery and I guess more responsive though. But I'm going to leave it at that. Of course, we could do an acceleration thing where it eases in and out depending on how far away we get from it, the center, but I'll just leave it at the player's movement speed for now. So if the center of our X minus the center of the game window, and then we just minus the offset to take care of the being out of place, not at the top left, then we scroll. And I'll show this one side. So we'll play. So if we go to the right, basically the map should start moving. Yeah, so now to the left and up and down don't work, but once we start going to the right, the map begins to scroll, because our X direction goes higher than the center of the game window. And once it's higher than the center of the game window, we start scrolling to the right. Or the map starts scrolling to the left, which makes it look like we're scrolling to the right, compared to everything else on the screen, relatively. So we should do the same thing for the other direction. elif, again, we can't be moving in two directions at once. So elif player rect.center x becomes less than rect.center x, meaning if we're to the left of the center of the game window, of course minus self.offset x, because we're just taking into account that the map may not be in its normal position. Then if we're to the left of the center of the game window, the game window's center, then what do? Well, self.offset x plus equals self.scroll speed. And self.offset x is, minus, not equals. So now, let's run this again, take a look at it. Now we should have left and right capabilities. Now we go to the right, now we go to the left. And of course, when we go to the left, we don't overgo. We don't go too far to the left. Because of course, we're not allowing it. If our offset in the x direction becomes greater than 0, then just make it equal to 0. So right now, it's less, it's like -2 or something. Now it's 0 because we moved all the way to the left we can. And the more we move to the left, it wants to become, 50, 100, 200, 300, but we're not letting it. So it doesn't actually scroll for us. And if we go all the way to the right, which shouldn't take too long, there's 20 boxes of these, or 21 boxes or something. But yeah, once we go all the way to the right, you'll notice the exact same thing. So, exact same logic for the top and bottom. If player rect.center y becomes greater than rect.center y, so if our y becomes greater, meaning we're on the bottom end of the map, of course, minus self.offset y, just to make sure we account for the map not being in a 0, 0 position, because it might not be. So if we're greater on the bottom, then the map needs to scroll up. No, if we're greater on the bottom, the map needs to go up, so it needs to scroll. It needs to minus self.offset y minus equals self.scroll speed, and then elif player rect.center y is less than rect.center y minus self.offset y, self.offset y plus equals self.scroll speed. So now we should have all the scrolling done. And we're getting something weird. I spelled center Y wrong. Somewhere. Right here. That's not a big problem. Just misspelling things. I will crash the game, but there we go. Now we should have scrolling. We don't scroll up because we're already at the top. We do scroll down, however. And you see we can scroll down until, of course, we reach the bottom, in which case it'll stop us. Because, we don't want to actually be able to go past the bottom. We can scroll to the right. We can scroll everywhere. Now, there's no margin of, movement. Like in the example, I had a margin of movement. This one, there's no margin because we're just checking the center of the game window only. We're not checking any other values. To create that margin that I had in the example, we need to subtract one more thing. So, if you look at it this way, let's look at the first one. If we're to the right of the center plus, something like 25. So if we're, more than 25 pixels to the right on the X side, then you start acting up. If we're more than 25 pixels to the left on the left side, then you start acting up. If we're 25 pixels above the center in the y-axis, start acting up. If we're 25 pixels below the center of the y-axis, start acting up. That's how that works. So now when we run it and we play, we don't immediately have that movement. We have to move a few pixels, 25 to be exact, before it starts reacting to us. Or I should say 50, because once we're on one edge, then we have to move 25 for the first one and then 25 for the next one. So now we have this little bit of margin. And of course we can tweak it from 25, maybe we want 100, maybe we want 50, maybe we want like 66 pixels or something, who really knows. We can change that up. So because this one's gone on a lot longer than I originally wanted it to, but you should get the idea on the maps. We'll fix the scoreboard and a couple of the other little issues later, probably next time, just to fully implement the map. But for now, you understand how we're going to draw the map, how the map kind of works by scrolling in the opposite direction we want to move, so it looks like we're moving, even though we really aren't moving all that much. But anyway, thank you for watching. Hope to see you next time.